All right, welcome to calculus. I don't think the homework went particularly well for a lot of people based on the questions that I was getting. So I want to go over, I'm going to pick and choose, to be really honest with you. I'm going to pick and choose. I remember like someone said I need everything but 2A and 3B or something like that. And someone else said I only got 2B and 3A. I can't even remember. So I'm going to avoid the first couple of 2 and 3, but other than that, I think I'm going to go over most of them. I believe that it may not be as bad as you think it is. And the reason why I say that is because I think it may just be a matter of where do you stop and where did the book stop? And where did you stop and where do I expect you to stop, and just stopping in general. So we're going to look at that a little bit, and hopefully you will be a little bit happier with your performance. All right, so in section 5.2, I asked you to do 2A, C, D, and G. So I'll tell you what, I will do 2, D, and G. That's the 2 I'm going to do. I'm going to do 2, D, and G. And I'm going to do 3D because I'm pretty sure I remember someone saying I got 3A, but I didn't get 3D. I will do all of 4, so 4 ABC. And, nope, sorry, I lied to you. I'm looking at the wrong day's homework. Let me look again. So you had to do 2A to E. So I will do 2 C, D, and E. How's that? Is that better? I will do, I think someone said I got 3B. So I'm going to do 3D and E. I'm going to do 7D and E. And I'm going to do 12C and E. So that's what I'm going to do. Hopefully quickly, but let's see. So I'm going to do these. I'm going to do them as far as I think I would take them. I'm going to look at the back of the book and see what they have as an answer and try and explain why mine are different, if they're different, and see what happens. All right. So 2C, I'm far away from it here. Root x cubed minus 9. Root x cubed minus 9. So let's just say that says y equals, and they want you to find the derivative. So again, I don't like it as a root, so I'm going to do it as to the 1/2. So the chain rule says, do the derivative of the quote-unquote outside first. So the thing that's on the edge, this exponent, move it down in front and decrease your exponent by 1. Leave the inside alone. Don't do anything to it. That's the first part of the chain rule. Just bring this down, decrease it by 1, leave the inside alone. That's the first part of the chain rule. The second part of the chain rule is now that I've done the derivative of that, just do the derivative of this inside, which would be 3x squared. And theoretically, that's it, but I think we can clean this up a little bit. On the top we have a 1 and a 3x squared. So the 3x squared can go on top. On the bottom we have a 2 because it's on the bottom of the fraction. And because this exponent is negative, it is also on the bottom. But because it's to the 1/2, that just means the square root. This is where I would leave it. Let's see what the back of the book says for 2C. For 2C, the back of the book says the same thing I do. Look at that. All right. So that's what I would do there. All right. So let's do another one. D. 2D says the fourth root of 2x plus 1. So the fourth root of 2x plus 1. So again, just y equals. So the derivative. First off, that would be 2x plus 1 to the 1/4. All right? If it's a square root, it's to the 1/2. If it's a fourth root, it's to the 1/4. So again, the first part of the derivative is take the exponent, move it down in front, and decrease it by 1. Leave the inside, whatever's inside the bracket, just leave it alone. Don't touch it. Don't do anything with it. Just leave it alone. So if I subtract 1 from 1/4, 1/4 minus 1 is negative 3/4. If you don't believe me, use your calculator. Now that I've done that, now that I've done the exponent on the outside, now I do the derivative of the inside, which would just be 2. So now it's a matter of what do I put on the top, what do I put on the bottom? Well, that's already on the top, that 1. That 2 has a positive exponent, it's 2 to the first, so 1 times 2, that's 2. On the bottom, we have a 4, and the negative means this goes on the bottom. It's a fourth root of 2x plus 1. Now you could either put the cubed here so that it's 3/4, or you can put the 3 here. It honestly doesn't make any difference, okay? Whether the 3 is underneath the radical or outside the radical doesn't matter. It's 3/4. The only other thing that you could possibly do with this is 2/4 reduces to 1/2, but I still have the fourth root of 2x plus 1 cubed. And again, if you put your cubed, if instead of putting your cubed there, if you put your cubed here, that would be fine, but you would need to have brackets around your 2x plus 1 because it's that whole thing that's cubed. So that's where I would leave it. The back of the book leaves it exactly as I have it. All right? So that's how I would do that. E. E, oh yucky, is 1/x² plus 6x minus 3 to the 5th. 1/x² plus 6x minus 3 to the 5th. Because we're dividing here, we could do the quotient rule with this, but I don't think I would. And here's why. Because there's only a 1 on the top. So it actually would be really simple for me to just take this whole piece, this whole denominator, move it to the top, and make the exponent negative. So it's like 1 times that. But the 1 doesn't really make any difference, so why would I bother putting it there? So if I were doing this, I think that's what I would do. All right, and so the derivative would be, again, the chain rule says I take the exponent, I move it down in front, leave the inside alone, decrease my exponent by 1, and then I do the derivative of the inside. So the derivative of this would be 2x plus 6. So now if I'm cleaning this up, negative 5 times 2x plus 6 would be on the top because that's there and that's there. But what has the negative exponent on it is that. So I would move it down to the bottom, x² plus 6x minus 3. Now the exponent is positive, And that's where I would leave it, and that's where they leave it as well. Yay me. Now, just as an alternative, if I didn't move it up, because I know someone's going to ask that, because every year someone asks that. What if I didn't move it up? What if I did the quotient rule with it? Well, if I did the quotient rule with it, it should still work out, because the quotient rule is gf prime minus fg prime all over g squared, right? So if I were to do the derivative of that, f is on the top, g is on the bottom. So leave g alone, x squared plus 6x minus 3 to the 5th. Do the derivative of f, but the derivative of 1 is 0. Minus, and I'm going to do everything from here, leave f alone, which is 1, and do the derivative of g. Well, the derivative of g, I'd have to do the chain rule with it. So I'd have to move the 5 down in front, leave the inside alone, decrease my exponent by 1. But now, because my exponent is positive, because I didn't move it to the top, 5 take away 1 would be 4. And then I have to do the derivative of the inside. So 2x plus 6. And that's all over x squared plus 6x minus 3 to the 5th squared. Now, because I have an exponent on an exponent, I multiply those exponents. When you have two exponents together like that, you multiply them. So that's really to the 10th. So y prime, that's gone. I have negative 1 times 5, that's negative 5 times x squared plus 6x minus 3 to the 4th times 2x plus 6 all over x squared plus 6x minus 3 to the 10th. Well, if I have 4 of these brackets up here, I have 4x squared plus 6x minus 3's, and I have 10 of them down here. These 4 will cancel 4 of these, and I will just have 6 of them left. So what do I have left? I have negative 5 times 2x plus 6 all over x squared plus 6x minus 3 to the 6th. I get the same answer doing the quotient rule as I did by moving it up first, but to me this was a lot more work, which is why I did it the first way the first time. So if this confuses you but the other way doesn't, then do it the other way, okay? All right. Three. 3D. They say find dy over dx. That still just means the derivative. We talked way back when about there's different ways to say derivative. There's different ways to explain it. Dy over dx is called Leibniz notation, and it still just means find the derivative. So for 3D, it's y is equal to 2x minus 2 squared. So again, the chain rule would say, bring your exponent down in front, leave the inside alone, decrease your exponent by 1, and then do the derivative of the inside. Well, the derivative of 2x minus 2 is just 2. So I really have 4 times 2x minus 2, which theoretically you could leave it there, or you could expand it out to be 8x minus 8. Back of the book for 3D takes out a common factor here and does 8 times x minus 1. If you left it here, here, or here, I'd be happy with that. All right? Really, all I want is you simplifying it a bit, but I'm more concerned with can you do the chain rule. So Yes, or yes, or yes. All good. All right? 3e says the square root of x squared plus 6. So again, rather than writing it as the square root, I'm going to write it to the 1/2. So the chain rule says, bring the exponent down in front. Leave the inside alone. Decrease your exponent by 1. And then do the derivative of what's inside the brackets, which would be 2x. So what's going to be left on the top is 1 times 2x. What's going to be on the bottom is 2 times the square root of x squared plus 6, because that's to the 1/2, so that means it's the square root. The negative means put it on the bottom. These 2's will actually cancel, and I can have x over root x squared plus 6, and yay. And that's what I would have, and that's what they have too. That's good. So far, I'm agreeing with them. I like it. So now we get to 7. 7, I asked you to do D and E. So for number 7, determine the derivative. For number 7, D, oh yay, 2x plus 1 times 4x minus 1 to the 5th. I am getting very old and it's getting very late. All right, so in this one, in order to do the derivative, I am multiplying two things together. I'm multiplying this with this, which means I have to do the product rule, which is g f prime plus f g prime. So g is this, f is this. So here's f, here's g. So to do the derivative, leave g alone, 4x minus 1 to the 5th. Do the derivative of f, and that appears to be 2. Plus, this time leave f alone, 2x plus 1, but I have to do the derivative of g. To do the derivative of g, because it's 4x minus 1 all to the 5th, I have to do the chain rule with that. So to do the derivative, first I bring the 5 down in front, leave the inside alone, decrease the exponent by 1, then do the derivative of the inside, which would be 4. So, what I have now is I have 2 times 4x minus 1 to the 5th. 5 times 4 is 20, plus 20 times 2x plus 1 times 4x minus 1 to the 4th. You could be done here. You could theoretically be done here. My guess is that is not where they stop at the back of the book, though. Oh, shoot. That's
all right.
Yeah, I'm fine. I'm fine. 7D, yeah. That is not where they leave it at all. So, here's what I would do with that, okay? In this, I have 4x minus 1 5 times, and in this piece, I have 4x minus 1 4 times. I have 4x minus 1 at least 4 times in both of these. If I take that out as a common factor, what I have left, if I take 4 of these out of here and put it here, I still have the 2 left, and I have 1 4x minus 1. I just have one of them, because of the 5, I put 4 of them out here. Common factor, okay? If you're wondering what I'm doing, think about a common factor, something really simple. Look over here. Hopefully this is in your screen. If you had 3x squared minus 9x, you could take a 3x out as a common factor and you would have x minus 3, right? That's all I'm doing here. all right? I'm just taking out a common factor. So I took out 4x minus 1 to the 4th out of here, and that's what I have left. If I take 4x minus 1 to the 4th and take it out as a common factor, I have 20 times 2x plus 1. This is easily simplified, because this would be 8x minus 2 plus 40x plus 20. And so I have 4x minus 1 to the 4th, and 8x plus 40x is 48x, and negative 2 plus 20 is plus 18. This is what they have at the back of the book. Yes, I expect that you should be able to do that. That is not an outrageous thing to do. That's not any magical math. That's not anything you haven't seen before in math. So yes, I would expect you to do that. So that was 7D, 7E. 7E. Now I have to find that page again because my book just went flying. 7E says, I don't know what, just a second. X squared minus 4 cubed times 3 minus 5x. And so again, we'll just call that y. So again, that is going to be the product rule. Whoops, I did that wrong, didn't I? Sorry. G f prime plus f g prime. So if I was doing this, again, here's f, here's g, leave g alone. Whoops, I really can't write now. 3 minus 5x. And do the derivative of f. But to do the derivative of f, I'm going to have to do the chain rule. So bring the 3 down in front, leave the inside alone, decrease that exponent by 1, then do the derivative of the inside. So I did g, all of that is f prime, plus, now I leave f alone, and I do the derivative of g, which is just negative 5. All right, so let's see what I have here. In terms of cleanup, 3 times 2x would be 6x times 3 minus 5x times x squared minus 4 squared plus x squared minus 4 cubed times negative 5. So again, thinking about that common factor idea, I think what I would do with this is I have at least 2 of those here, and I have at least 3 of those here because there it's squared, there it's cubed. So I'm going to take out x squared minus 4 squared as a common factor. And then I'm going to say, okay, if I take that out of here, what I have left is 6x times 3 minus 5x. And if I take 2 out of here, I have x squared minus 4 times negative 5, right? And I just have 1 of them left because I took 2 of them out and put them here. So now let me clean up the inside a little bit. So I have x squared minus 4 squared. Here, I'm going to have 18x minus 30x squared minus 5x squared plus 20. So if I clean that up on the inside, x squared minus 4 squared times negative 30x squared minus 5x squared is negative 35x squared, and 18x, so just plus 18x plus 20. That's probably where I would leave it. I'm bending down so that the same thing doesn't happen again. That's where they leave it as well. So that's what I would expect you to be doing. So hopefully where your mistake was not so much necessarily with the chain rule as it was with the simplifying. I'm hoping. I could be wrong, but that's what I'm hoping for. 12C, again, says determine the derivative. 12C, oh, I just love you so much. X squared plus 1 over x plus 1 all to the 8th. And it wants us to find the derivative of this. Yay! Not going to be so much fun. I can tell that just by looking at it that you're not going to like me too much. Sorry. All right, here's what I would do with that, I think. Bless you. Here's what I would do with that. If both of those are to the 8th, I can write that as x squared plus 1 to the 8th over x plus 1 to the 8th. I think I'd write it that way. That's where my brain's headed. I don't know. If I do that, I am dividing two things. I'm thinking quotient rule. I'm thinking g f prime minus f g prime all over g squared. That's what I'm thinking. I'm not happy about it, but that's what I'm thinking. So if I'm going to do the derivative of that, what's on the top is f, what's on the bottom is g. So leave g alone. X plus 1 to the 8th. Do the derivative of f, but to do the derivative of f, I have to do the chain rule. I have to bring the 8 down in front. I have to leave the inside alone. I have to decrease my exponent by 1. And then I have to do the derivative of this inside, which would be 2x. So that is the g f prime part. Minus, and I'm subtracting all of this from here on, f, which is x squared plus 1 to the 8th, times g prime. Now to do the derivative of this, I have to bring my 8 down in front, leave the inside alone, decrease my exponent by 1, and then do the derivative of the inside, which would just be 1. That is all over g squared. Well, g is x plus 1 to the 8th squared. What I said in the last question like this was when you have an exponent on an exponent, you multiply those. So 8 times 2 is 16. So I have to the 16th. All right, this does not look happy at all. So what can I clean up here? What can I clean up here? Let me see. I can do 8 times 2x is 16x times x plus 1 to the 8th times x squared plus 1 to the 7th. Okay, so all I did was I took this and this, multiplied it to give me that, and I still have those two pieces. All right, so this just simplified down to this. Minus. Again, the only thing I really could do is 8 times 1 is 8, and I still have x squared plus 1 to the 8th times x plus 1 to the 7th, and that's all over x plus 1 to the 16th. Running out of space, so I'm going to erase up here a little bit because I need to. Okay, so now I have this, and I'm trying to simplify it if I can. On the top, I'm going to think about a common factor. What is the same about both of these? Um, well, in both of these, I have x plus 1 to the 8th and x plus 1 to the 7th. I have at least 7 x plus 1s in both of them. And I have an x squared plus 1 to the 7th and an x squared plus 1 to the 8th. So I have at least 7 of the x squared plus 1s. So what do I have left when I do that? What do I have left? If I still have in this piece right here, if I take that out, I still have the 16x. X plus 1 to the 8th, well, I only took 7 of them out, so I still have an x plus 1. And I took all 7 of the x squared plus 1 out. So that's what I have left there, minus. I still have the 8. X squared plus 1, I had 8 of them, but I took 7 of them out, so I still have an x squared plus 1. I just have 1 of them left. And I took out all 7 of those. So that's what I have left. All over x plus 1 to the 16th. Now, x plus 1 to the 16th, x plus 1 to the 7th. I have 7 of them up here, I have 16 of them out here. So if I cancel 7 of them here, 16, take away those 7 would be 9. So I've gotten rid of all of those. I have x squared plus 1 to the 7th because I canceled 7 of those with 7 of these down here, so I just have those left. Here I have 16x squared plus 16x minus 8x squared minus 8, because I just expanded all of that, all over x plus 1. Now I took 7 of the 16 away, which means I just have 9 of them left. I'm almost done simplifying. The only thing I think that I could do from here is I could simplify this a little bit. So I have x squared plus 1 to the 7th. 16x squared minus 8x squared is 8x squared plus 16x minus 8 all over x plus 1 to the 9th. That is probably how I would give my answer. Y prime is. I would probably leave my answer like that. You could potentially take a common factor of 8 out of here and have 8 times x squared plus 1 to the 7th times x squared plus 2x minus 1. But there's no real point to doing that. So 12C, that's where I would leave it. They have, so helpful if I can find the answer. Yeah, they took the 8 out. So rather than leaving the 8 in here, they just took an 8 out as a common factor. I don't care whether you do or not. So rather than do this, they took the 8 out. So that would be a 2, and that would be a 1, and they put the 8 out front here. They did that, but I don't care whether you do that or not, okay? But that's where they take it. All right, that's 12C, last one, thank goodness. 12E, it's a long video, sorry guys. 12E. 2x minus 1 cubed over x squared plus 1 cubed. Now they have the whole thing cubed, but again, I would just write that as they're both cubed. And I would do, again, the quotient rule with that, except that's not E, that's F. Let me do E. Let's do the right question. Let's do E. 3x minus 2 cubed and 2x squared plus 5 to the 4th. Okay, so this time we're multiplying things. I gave you one that was dividing, one that was multiplying. So this one is the product rule. So again, first bracket is F, second bracket is G. So if I'm going to do the derivative, leave G alone, 2x squared plus 5 to the fourth. Do the derivative of F. Now to do the derivative, I have to do the chain rule. So I'm going to bring the 3 down in front, leave the inside alone, decrease my exponent by 1, then do the derivative of the inside, which would just be 3, right? Because the derivative of 3x is 3. Plus, now we leave F alone, 3x minus 2 cubed, but we do the derivative of G. So we bring the 4 down in front, leave the inside of the bracket alone, decrease my exponent by 1, and then we do the derivative of the inside, which would be 4x. All right, so now we have to clean this up. I would do 3 times 3, that's 9, times 2x squared plus 5 to the fourth, times 3x minus 2 squared. So all I did there was multiply the 3 times 3 to give me 9 and write out the 2 brackets. Here, I would have 4 times 4x, which would be 16x, and then I'd have 3x minus 2 cubed, and 2x squared plus 5, also cubed. So again, technically that's the derivative. However, professors like it when you clean it up. So I'm going to think about common factors. And again, you can usually do that a couple of different ways, but I'm going to think about what is the same here. I have 2x squared plus 5. I have 4 of them in this piece, and I have 3 of them in this piece. So I have at least 3 2x squared plus 5s in both pieces. 3x minus 2, I have that it's squared there, but it's cubed there. So it is at least squared in both. So that's what I would think about for common factors. So now, if I took 3 of these out, I only have 1 of them left. So I have that 9, and I have 2x squared plus 5, and I took both of these out. Plus, I have 16x, 3x minus 2 cubed, 3x minus 2 squared. So I took 2 of them out, which means I still have a 3x minus 2 left in here, and I took all 3 of those out. So that's what I have there. So I have 2x squared plus 5 cubed times 3x minus 2 squared, and then what would this be? This would be 18x squared plus 45 plus 48x squared minus 32x. And so 2x squared plus 5 cubed times 3x minus 2 squared times 18 plus 48 is 66x squared minus 32x plus 45. Again, theoretically you could break up in there a little bit. I don't think I would bother. They don't bother. So this is my answer. Ta-da. All right, that's all we're doing today is we're just going over homework with the chain rule. Hopefully this answered your questions. If it did not, we will maybe have to do a video meeting or something and see if we can't figure out where it is you're going wrong. Is it the chain rule itself, or is it in the simplifying that the problem is? I hope by going over these that you kind of see where the thought process was. And hopefully your mistake is more in the simplifying and less in the chain rule portion of it. I do find that's usually the case. So again, you might need to rewatch a couple of these examples a couple of times just to see. Play me in slow motion. I don't know what I'll sound like in slow motion, but you know. Yeah, I'm working on getting your assignments marked. You're next in my pile. And yeah, so we're gonna make sure that we get this figured out before we move on to the next section. So if you watch this video and you are still lost, then maybe what we'll have to do is arrange like a quick video meeting to answer questions that you have. I don't know how I'm gonna say it any different, but I can try. Maybe just seeing me live, I don't know. Maybe seeing me live will help, I don't know. Yeah, so I guess that's it. Again, if you just watch the video, that's your only work today is just to watch the video, look at your work, see where you went right, see where you went wrong, make sure you understand it. And if you don't, please let me know that you don't. Beyond that, that's all you're doing today. All right, talk to you again soon. If you're in physics, don't forget your assignment's due tomorrow. Okay, bye.